Hi everyone and welcome to this video. Last time we have been discussing about the Amiga Basic and how close it is to QBasic, and actually I have shown a few examples to clearly show that this is the case, that if you know QBasic then Amiga Basic is pretty easy. This time we are going to do something similar, but rather than using the Amiga Basic, we are going to use the Commodore 64. So if you have a Commodore 64 at home, this is very good. If you don't have it, no worries. You can use plenty of emulators that are around. I am suggesting these two here, and you can install any of these two. I am personally using this one, CCS64, for the test that you will see in this video. So of course the very first thing that we are going to do, we are going to go through the 8-bit basic environment, because this is something I would say different if compared to QBasic. So one has to get familiar on how to use that environment. And while explaining this, I will also show how to use line numbers to actually edit or create basic programs on the Commodore 64. Of course, all of these will happen through examples, so if you want to run these examples, you will be able to do this either on the Commodore 64 itself or on the emulator, and I strongly suggest you to follow those examples and to try to understand them. While creating these examples and showing how they work, I will introduce new commands in this video. The first commands will be new, list and run. You will very quickly understand what they do. Then I will introduce load and save, and eventually Goto and GOSUB, and finally pick and pock. So all these commands are commands that you will not see in QBasic, because either they are not useful or they are not considered to be good practice, but these commands are absolutely necessary on an 8-bit basic environment. To conclude, if you haven't seen my previous video on the Amiga Basic, you can follow the link here that is also reported in the description below. And as always, I want to take a few moments to thank all of you for subscribing on this channel. This is very encouraging. This is pushing me to provide more videos like this. So thank you so much for doing this. So let's see now how this 8-bit basic environment work in the case of the Commodore 64. And the screen that you see here is exactly what you would see on a real Commodore 64 if you turn it on. The same thing you will see if you use an emulator. So this is the very first screen when you turn on the machine. And as you can see, there is no shell here, so there is no way to call an editor. All these things were not invented at the time, or were not available on such very limited machines. So how does it work? How can you use this environment to edit or to create new basic programs? Well, the very first thing that you have to consider is the fact that since there is no editor, we are going to use line numbers. What do I mean by this? So here what you see, it's an environment that is completely interactive. Every time you type something and then you press enter, this interface is going to react. So one way to say to the interface that you are actually inputting a program is by using line numbers. What do I mean? In this particular context, think of a program as a list of let's say, commands, and this list of commands as an order. So since it has an order, you could use actual numbers to provide the order of the commands. Let's say that you want to print 3 strings, and these 3 strings are the word 1, the word 2, and the word 3, and you want them to be printed in exactly this order, 1, 2, 3. So you could do one thing. You are going to say that the first command consists of a print, which prints the string 1. Then the second command is a second print that prints the string 2, and the third command is going to be another print that is going to print the word free. So now if I use the command list in this environment, what you can see is that it's showing me the order list of commands that I have provided, or in other words, it's listing my program. So if I now want to run this program, this becomes very simple. I just have to use this run command here, and if I press enter, you see what happens. I have the 3 strings that I wanted, which are 1, 2, 3 in the order that I requested. So in practice now, in this basic environment provided by the Commodore 64, a program is essentially a list, an ordered list of commands that you have to provide through the use of line numbers. So if I now use, let's say, the command new, I'm practically erasing everything that is in the memory. So if I do list again, now there is nothing. As you can see, there is no program anymore. So I'm going to show you how to use line numbers, but to achieve something slightly different. So far we have been using the numbers 1 to 3, but in this particular context this is not a good idea. What I mean is the following. If instead of using 1 to 3 we would be using, for example, let's say 10, 20 and 30, the program would now look like this one. So I'm just retyping everything, but rather than using 1 to 3, I am now using the numbers 10, 20 and 30, just like you see here. Now if I run this program, and I'm hitting run here, as you can see, it's providing exactly the same output that the previous program was providing, just that rather than using the line numbers 1 to 3, we have been using 10, 20 and 30. Why we decided to go in tens? It's very simple. Let's say that I forgot to print something between the string 1 and the string 2. Now I can use the line number 15, for example, and add what I missed. Let's say that I missed 1 space and 2 symbols like this, and then another space, and then I close the string. So now if I do the listing of the program, as you can see, it still follows the order, but I have been able to insert 1 command between line 10 and line 20. If I kept the previous program in the previous, let's say, line numbering 1 to 3, there would have been no way for me to add this extra print command in the listing. I should have started from scratch. So every time you are programming something in this kind of an 8-bit environment, I highly recommend you to use always line numbers that goes in tens, so that if you forget something, you can still add it. There are 2 further commands that I would like to explain here, which are very important, but you will have to go through the manual of your Commodore 64 or through the manual of your emulator in order to understand how exactly this command works. So the very first thing, you have seen that we can list a program, we can run a program, but we can also use the command new to erase the memory. In that case, we are losing the program. The same thing happens if we turn off the machine or if we turn off the emulator. So there is one simple way to save your program, and the way you save it is by using the command save, and it works like that. So you use the command save, you add the name of the program, let's say it's prog01, in this case .bas, and then you have to provide where you want to save your program. So say that your Commodore 64 is connected to a disk drive. In that case you could say ,8, which means this is the first disk drive that you have connected to the machine, or you could actually use the number 1 in case your computer is connected to a tape reader. And in the very same way, once you have saved your program, you have a way to actually load your program, and I'm going to show you how this works. You just have to use the command load. And how does it work? You are going to provide the name of the program that you want to load, and then you use comma and you say where you want to load this program. So in the case of a tape, you are going to use 1, and in the case of a disk drive, you are going to use the number 8. Let's now talk about two different commands which are of paramount importance in 8-bit basic environments, and which we are going to use pretty often if we develop programs in this environment. So the very first command that I'm going to explain is Goto, which is supposed to be bad practice if you use it in QBasic, but it's not considered so in this kind of basic. It's actually very useful. And what the command Goto stands for, what does it do? With this command, you can actually change the order of execution of your program. So let's try to make a simple example to see what I mean. In this particular program here that is still in memory, we have 4 commands. These are 4 print commands, and these are in lines 10, 15, 20, and 30. So the order of the program, if we type run and hit enter, it's going to be the following. It's going to run the first command that is at line 10, then the second command that is at line 15, and then the third command at line 20, and then the last command in line 30. But let's say that now we want to change slightly things, and we would like to have line 10, 20, and 30 that are executed in order, and then line 15 has to be the last one. So one thing that we could do is we could introduce line, for example, 12, and say that we want to jump to line 20. So if we now list the program, this is what we get. We have line 10 where we are printing the string 1. Then we have line 12 that tells the program to skip, to jump on line 20. So it's going to go on line 20 and completely it's going to ignore line 15. So now we have the command at line 20 that is print 2, and then we have a command at line 30 that prints 3. But now we would like to print what is on line 15. So one thing that I can do is to add a new line, let's call it 35, that jumps to line 15 where there is this command, and then at line 16 we are going to end the program. So if I now list the program, you see that it's starting to be slightly complicated, but if you follow the reasoning, you will see that the program is going to print 1, 2, 3, and eventually the 2 minus signs and stop the program. So let's see if this is the case. Let's type run, enter, and as you can see, this is what we get. We have 1, 2, 3, and then we have the string with the 2 dashes. So as you can see, Goto is a command that helps us to change the flow of information in the program, or let's say the flow or the behavior of the program. And the way it is done, it's by simply telling where to jump. So this can make the program slightly more complicated to read. Of course, that's why at some point it's been said that Goto is definitely not a good practice if you use it. But you can see the utility, the necessity of such command in such a very, very limited environment. In the same way, we can also introduce another command that is called GOSUB, and this command is just going to run a routine. The way you are going to say where the subroutine is essentially by providing the line number of the routine. So in this case, for example, the program would jump at line 200 and run everything that it finds from that line on. Let's try to make things slightly more interesting. Let's say that we still have the program in memory, but this time at line 16, rather than using AND, we are going to replace that line by saying that now line 16 jumps at line 200. And now we introduce line 200, which makes, let's say, this computation here, let's say 3 times 4, and then we want to go back to where we were. So at line 210, we are going to introduce this command, which is called return, which is going to go back to line 16 where everything started. So now if we add, for example, line 17 and we add the command N, we can list everything and we can understand more or less what's going to happen. So if we run this program, the very first thing that is going to do is to print the word 1, which is at line 10. Then line 12 is going to jump to line 20 because it finds a Goto 20. Then at line 20 we have a print 2, so this is what we are going to see on the screen. Then the next command on line 30 is going to print the word 3. But then at line 34 we go back to line 15 where we have the 2 dashes, and eventually we go to line 16 that go to the subroutine that starts at line 200. So at line 200 there is going to be a print, the print of the result 3 times 4, and then at line 210 there is a return. So the program is going to return to the next line after 16, which is line 17, that ends everything. So let's type run and let's try to run this program to see what happens. And as you can see, we have everything in the right order as we expected. So we now have 2 different commands that are very useful in this 8-bit environment, which are Goto and GOSUB. You can experiment a little bit with these commands, but as you can see, they are pretty simple to understand. So finally, we are going to go through 2 more commands which are very specific to this kind of 8-bit environment, which are pick and poke. What do we need and why we have these commands? For these very limited machines, you have to understand that memory is something that you can access directly. There is not an operating system between, let's say, BASIC and what you can access in the memory. So you can use these 2 commands to actually set values in the memory or to read values in the memory. The memory on this kind of machines is organized in addresses. So if you have a number that is the address, essentially this is all you need when you treat in terms of memory. So let's say that you want to know what is the value of the memory cell number, let's say 128. You would have to print a pick of the cell 128, and if you do this, it's telling you that there is a value that is stored there, and the value is 201. In the very same way, let's say that you want to change the value of the cell or the address 128, and you want to change it with the value, let's say 23. So this would be the command that you actually use to do this, but you have to be very, very careful with these commands pick and poke, because you have to remember that you are directly assessing the memory of the machine now. So depending on what you are going to modify, you can actually get your machine stuck, and there is no way you can recover from there. So we are not going to use these 2 commands today in this video, but they are of paramount importance for other tricks that we are going to explore later on in other videos. So now you know that they exist and you know how you can use them. Let's run our first example now, and the example that we would like to implement here is a program that prints, let's say, 10 different random numbers. So the very first thing that we are going to do is to create a for loop, and as you can understand here, the for loop close looks very close to the for loops that we were defining in QBasic. So if I open this for loop here, I can close it somewhere else, let's say at line 30, by simply typing next I, and then at line 20 I'm going to ask this to print I and then to print random numbers between 0 and 1. So if I now list the program, as you can see, this is what we get, and if I run it, this is what we get. And as you can see, in the first column we have the index I that runs from 1 to 10, and in the second column we have random numbers that ranges between 0 and 1 as expected. And as you can see, the code or the program is not that different from what you would have implemented in QBasic or even in Amiga Basic. It's just that now we are using line numbers, and this is the only thing that makes things different. But once you get the hang of it, it becomes very simple to program the Commodore 64, more or less in the same way you knew how to program a computer with QBasic. Now let's make things slightly more complicated, and let's suppose that we have a range of temperatures in Fahrenheit that goes from 100 to 200 in tenths. And what we want to do is to convert every single temperature from Fahrenheit to Celsius. So the way we are going to do this is very similar to the previous examples that we have done in the previous videos. And we are going to use exactly the same formula, but this time we are going to use the Commodore 64 BASIC for that. So the very first thing that we need to do, as usual, is to define, let's say, a for loop for the temperature that goes, let's say, from 100 to 200, and this we said in step of 10. And then we have to close this loop, let's say at line 50 by typing next T. So now we have to create the body of this for next loop, and this is the way we are going to do this. So at line 20 we are going to define a variable called C, and C is going to be equal to 5.0 times, and then we are going to have the temperature in Fahrenheit minus 32.0, then we close these parentheses and we divide by 9.0. And then at line 30 we want to print all of this. So in the first column we are just going to print the temperature in Fahrenheit, and in the second column we are going to print the same temperature but in Celsius. Now if I list this program, this is the way it looks like. As you can see, it's not that different from what we knew previously. And if I run it, as you can see, it's providing what we expected. On the first column we have temperatures in Fahrenheit that ranges from 100 to 200 in steps of 10. And on the right column we have the corresponding temperature in Celsius, exactly as expected. And as you can see, the program is not too different from what we were expecting. It's not so complicated to program the Commodore 64 once you know QBasic, for example. And we can now go through the last example of this video, which is going to be slightly more sophisticated. So let's suppose that we want to know what is the sum of the first 100 numbers. So what we are trying to compute is 1 plus 2 plus 3 plus 4 plus 5 plus so on until we get to 100. The way we are going to do this is, of course, through a program, and this is the way we are going to do this. So in the very first line of the program we are going to set the sum equal to 0, and then we are going to start here a for loop that goes from 1 to 100, since this is the number of numbers that we want to sum. Then we close this for loop. Let's say that, okay, I lost the cursor, as you can see, so I'm going to use the arrow keys here. But the last line that we need to insert here, first of all, is the closure of the for loop, and we are going to do this at line 50. Now we have to define the body of the loop, and the way we are going to do this is at line 30 we are going to say that the sum is equal to its previous value plus the current value of the index I, so that in this way we have the sum of 1 plus 2 plus 3 plus so on until 100. And finally, at line 60, I want to print the value of sum, but I also want to use, let's say, a formula that is going to tell me if this sum is correct or not. So if we say that we want to sum n numbers, then we could use this formula here. The result will be n times and then n plus 1, then we close parentheses here, and finally this is divided by 2. So now, as you can see here, I have introduced a variable n, but there is no n defined in the program. So what I'm going to do, first of all, I'm going to remove this 100 here and substitute it by n. So now if I push enter, this is practically the new line that I have in memory. And since n hasn't been defined anywhere, I'm going to define it at line 5, and I'm going to say that this is equal to 100. So if I now list this program, this is the way it looks like, and I'm going to run it just to see if everything works. So let's type run and enter, and as you can see, the two numbers are the same. Now if I want to try something different, I could say that this time line 5 is the following. N equal, let's say we want to sum the first 200 numbers, so this would be the way we do this. Now if I list it, as you can see at line number 5, I have n equal to 100, and if I run it, now I get something slightly different, but as you can see, the formula tells us that this value is correct. You have noticed that this code is slightly slower than the previous one, which makes sense because now our for loop, rather than going from 1 to 100, it's going from 1 to 200. So this is something to bear in mind when we write basic programs on such limited machines. This concludes this video for today. As always, thank you so much for being here today, and see you in the next video.